Hello, my name is Jonathan Olson, and today I will be discussing the articulated cord delivery robot project nicknamed Coiled Segments. This device was produced by Corey Milsick, Colin Brady, myself, and Christian Stavry. I want to start off by talking about the stated purpose of the device, and that is to successfully unwind one segment of 25-foot long cord. Could be extension cord, it could be a variety of different types of cord. Return to the starting point, be mounted or fitted with a second segment, return to the end of the first segment, successfully connected to, and then proceed to unwind the second cord segment, totaling 50 feet of cord, having been successfully unwinded. That is the primary purpose of this device. There are some other elements to it, primarily related to automation, and I will go into that in just a moment. Talking about the crucial elements of this project, or of the design, in order to successfully complete phase 1 and phase 2, not related to automation, we have the connection of the two cords, and we have the ability to facilitate that connection, so related to that. And these two things are absolutely crucial to the device, to the design of the device. The connection of the two cords, we decided on a magnetic solution. Both cord 1 and 2 are fitted with a magnetic head and are positioned to be connected at the end of phase 1. Now, since the chassis of the device sits about 4 inches off the ground, 3 to 4 inches off the ground, making this connection is actually quite challenging. The solution we proposed initially, this was actually part of the very first, one of the very first iterations of this design solution, was to have an actuated lever or a sled of some sort actually pull the second cord or the head of the first cord into position, allowing the connection of the second cord much more easily. So this design decision made it into the final version, and like I said, it is crucial for making that connection. This actuated sled positioning device is powered by a single stepper motor mounted to the top of the chassis and connected by slot and pin to the sled itself. I want to transition into talking about automation capability and outfitting on the device. There is some discussion of automation in the initial design prompt, and while we consider it to be important to explore these types of solutions and have the device be potentially retrofitted for automated functionality in the future, it was not crucial to achieving the stated purpose, successfully completing phase 1 and phase 2. So the final product, the final version of the device, does not actually operate autonomously, although it does have the ability to, and I will discuss that briefly. Automation capabilities or sensors related to automation are a ultrasonic proximity sensor mounted on the front of the device, right next to the camera. The camera is used for, the camera is mounted underneath the device in the front and has 195 degrees of motion, a single degree of motion, or single degree of freedom, and is used for two reasons, or for two purposes. One being piloting the device, and the other, the camera can be spun around to actually point directly at the sled and ensure or help to facilitate the connection of the two magnetic heads. So, just a quick recap related to automation. There's object avoidance, and that's achieved through an ultrasonic proximity sensor. And there's line following capability. Line following sensor is not currently mounted, although the proximity sensor is. The line following sensor is an infrared sensor, and the primary challenge presented by this solution is the interference of outdoor light. So if this were to be retrofitted for line following capabilities, it would need to be utilized indoors. So, just as a quick recap, stated purpose of the device to uncoil 50 feet of cord in 2 separate segments. In order to achieve this, the 2 cords must be connected without the direct assistance of any team member, and this is accomplished via the actuated sled, which is used for positioning of the head of the first cord segment at the beginning of phase 2. As I stated, this device can be easily modified to utilize automation. However, it is not necessary for the final version of the device and is currently not in this state. Hello, my name is Jonathan Olson, and today I will be discussing the